Hi, welcome to a new day. Yesterday we worked on standard modules. The time module is an example of a standard module. So these modules come together with a Python interpreter that we installed. And so usually these modules give us access to methods and functions which are not so commonly used compared to things which are immediately available in Python, such as the if conditional, the while true loop. So these modules give us access to more specific functionalities, such as getting the current time using the time module. So standard modules was one thing we learned yesterday. The other thing is that you learned that you can define these kind of variables. So this is still a variable, but when you write it with capital letters, that's like a convention that you are saying to yourself or to other programmers who will read your code that, oh, this variable is like a constant. So you usually define it on top of the program, and then this value will be used throughout the script. So it's better to have that object tied to a variable and then use the variable name throughout the code. You also learned about if name is equal to main. So what this does is basically protecting these two lines. So these two lines now are only executed when this functions.py file is executed directly. And these lines are not executed when you execute the other script which imports the functions.py file. So this is to control the execution of this script. So basically, if you want to call these functions from within this file, then you wrap them inside this if name is equal to main, because this is only true when this script is executed as the main file. I hope that is clear, and let's do some more coding today. So I'll see you in the next video. I'm super excited to introduce you today to building graphical user interfaces with Python. And by the end of this series of videos, you will learn how to build this exact program. So what you see here is the program, the to-do app program that we have built so far, but the only difference here is that now we have a graphical user interface, or GUI for short. It is called a graphical user interface because the user can interact with the program graphically, so they can click items, they can type in text boxes, they can press buttons. So in the command line, all that was not possible. In the command line, so far, the user was only able to write in text and execute that text, and also see text. The good news here is that all you have to write is the front end. So the backend is this functions.py program. We're not going to touch this, so all we have to do is just write a new main.py file, and the code will be slightly different because we're going to have to use some objects, some types which create these buttons and windows. And then these types are going to be using the same exact functions that we have written already. So that brings us to the point of how important it is to write functions. If you remember previously in the course, we had this code integrated into the main.py file. So we didn't have functions, and if that was still the case, and the code was here, then it would be a mess to modify this program now or to extend it. So it would be much harder to create this graphical user interface. But with functions, things are separated, so things are decoupled. The front end which is this, which creates the command line interface, is decoupled from the backend, which does the processing. So this interacts with the data, the todos.txt file, and gives us the data in a well-structured format, such as a Python list. So that Python list can be used by this command line interface, and it can also be used by the graphical user interface, which we're going to build in the next videos. So front end is the code base that constructs the user interface, be it command line or graphical user interface or GUI. So front end is the code base, and the back end is also the code base, which does the processing part and communicates with the front end, sending data to the front end code base. So again, that's the program. You can add here more to-dos using the add button. You see that to-do is added. You can edit to-dos, so do the laundry. You can just click there and say today, do the laundry today, press on edit, and that is updated. You can complete items. For example, we can complete take the course, so press on that button while selecting that, and that item is deleted from the list, and you can exit the program using that exit button. So that's what we're going to build next. Let's start in the next video. See you there. Hey, welcome back. By the end of this video, you will have learned how to create this graphical user interface. This has 4 elements. First, it is the window, which contains everything, the window element. Then it contains this label, which writes type in a to-do. Then it contains this input text box, and then it contains this button. So you will learn how to create all these 4 elements: the window, the label, the input box, and the button. Let's begin. This here is the command line interface, the code base of the command line interface. What I'm going to do now is I'm going to rename this by going to refactor and going to rename to something else, such as CLI, which stands for command line interface. You can put whatever name you want, but I would suggest not to keep the name main.py. We generally use main.py when we only have one front end, and we know that main.py is the entry points of our app, so that's the script we actually execute with Python. So we don't execute functions.py, we execute it main.py. But now, since we are developing more than one interface, I want to keep this as it is, give it a more meaningful name, and then create a new Python file and call it GUI.py. Although, even if you don't type .py in PyCharm, PyCharm will add .py by default. Now, as soon as I created that GUI.py file, I got this window popping up. This window shows up if you have enabled Git in your project, in your PyCharm project. And I showed you how to do that yesterday in the yesterday's programming tool video where I covered Git. So in that case, you want to press add, and that will add GUI.py in the list of versioned files. So Git is going to keep track of this file if we press add here. So press add. Alright, let's continue coding. So now we have an empty GUI.py file. And here is where we're going to write the graphical user interface. First of all, we want to import functions, because we're going to need these 2 functions in this GUI as well. Then, what type can we use to create a window, a text box, a label, and a button? So is there in Python something like a window type or a button type? You know, like we have a list type, but no button type or window type. So these kinds of objects, they don't exist by default in Python. They are not included. Python does have a standard module called tkinter or tkinter. So that's a standard library, but I would prefer to use a more advanced library. And this advanced library is made available as a third-party module or library. The word module and library are used interchangeably. So I introduced you to standard modules previously yesterday, and you can also refer to those modules as standard libraries. The same we can say for third-party libraries, third-party modules. So what are third-party modules or libraries? Well, these are Python files which other people have created, and we can get those Python files and use the functions written in those Python files. So somebody else created functions which generate these window types and button types, and we can just use these to create instances of those buttons, instances of those text boxes, instances of those windows. A complete list of Python third-party libraries can be found on pypi.org. So that is the repository where everyone can create such libraries, and they can upload them to this site, and everyone then can use these Python libraries. I'll show you how to use them. For example, if I search here for and I press enter, this first result, free simple GUI, is the library we're going to use to create our graphical user interface. So the Python files of this library contain those special types, the button, the window, etc. If I click over here, it's going to take me to the homepage of this library. And up here, you see this pip install free simple GUI. That is the command that copies all the Python files of this library and puts them on your computer. So then you can use those types. So therefore, I want to copy this, go to PyCharm, and then I'll show you two different ways to install packages. The first way, which I do recommend you to use, especially if you are using PyCharm, is to go to PyCharm and then to preferences or settings, wherever it shows here, and then go to project. That's the name of my project. Expand it, go to Python interpreter, and down here you will see the list of third-party Python libraries. Now these are by default included, but you can add more using this plus icon. And here you want to search for free simple GUI. It's one word, no spaces, and install that package by pressing on this install package button. So package py simple GUI installed successfully. So now I can close this window, press OK here, or exit, whatever, and then import free simple GUI. And that's how you import the module, the library. So just like we do with functions.py, we also do this with this library, which is also a Python file. So if I right click here and go to and implementations, we're going to see that this is actually a Python file. It's called __init__. It's a spatial name used for libraries, and it tells us that this file is importing other Python files from other places. So there are multiple Python files which basically import each other. So these are details that we don't need to worry about for now. All you need to know is that these are Python files, and these files contain some types which we're going to use to create instances. So that was one way to install the package. Another way is to go to the terminal. And here you want to type in pip install free simple GUI. So that is the command that we saw in the homepage of the library, that one in there. So what is pip? Pip is also a third-party library for Python, and pip is used to install other third-party libraries. So it's available in the command line. Now don't confuse the terminal with the Python console. So pip is used in the terminal, not in the Python console. Press enter. And if you get this, that means pip is not recognized by your computer. That is mostly the case when you have different Python installations on your computer. In that case, you will have to press the upper arrow key to call that command again, then go with the left arrow key to pip and write 3. So we want to try pip3 install free simple GUI and then press enter. And the package will start to install. Now, you only have to do this if the other installation method didn't work for you through the graphical installer. But I still wanted to demonstrate this method in case you are on another IDE other than PyCharm. Now, once you do this, try to import free simple GUI. So if you try to execute with right click and run GUI, if you don't get an error, that means free simple GUI was installed successfully. If you get an error such as the module was not found, that means PySimpleGUI was not installed. So in my case, it was installed successfully. I can go ahead and create an instance of a window type. So just like we have the list type, and we create instances of that list using that syntax, in here we have something called window. So that is a type. Just like list is a type, this is also a type. Sorry, this has to be free simple GUI. Now this is the type, but what is the instance? The instance in the case of a list is that. In the case of a string type, it is something in quotes, right? That is an instance of a string type. An instance of a window type is this in parentheses. And here you insert the values that window gets. So this looks like a function call, but it's not a function actually. Indeed, this is actually a capital W. So sorry for that. This is uppercase W. And now inside this parenthesis, you can place a string. You can say my to do app, for example. And this will be the title of the window. So just like lists have these values, so these are the components of the list instance, this is the content of the string instance, this is also an element of that instance. You know, I love the cafe analogy to explain your types and Python elements, so I'm going to talk about that again. Let's say in the cafe you order a pizza. The problem is the cafe only makes coffee instances and tea instances and things like that. They don't make pizzas. However, they offer this service that they order the pizza for you from a third party. So they order it from a pizza shop nearby. The same is happening here. Python doesn't have window objects by default, but we can get those object instances from other third parties. So Python doesn't have everything because it would become very heavy. The same goes for that cafe. It would become a mess if they had everything. So it's better for some things to get them from third parties. So the free simple GUI part here is the pizza shop, and the window open parenthesis my to-do app close parenthesis, that is the actual pizza instance. And you could say that my to-do app, that part, is what pizza you want, so capricciosa or quattro formaggi or cinque formaggi, whatever pizza that is. In our case, this is just the title of the window instance. I hope that makes some sense. Now, this window type also needs some other elements. It needs a layout, which for now I'm going to just put it an empty string, and that's it. So that is an instance. But currently it doesn't have a variable associated with itself. So I'm going to create a variable here, call it window, or other name, whatever you like. And so that instance now is stored in this variable. Then you use the read method of that instance. So just like strings and lists have their methods, such as test.capitalize, you get that. This method, what it does is it displays the window actually on the screen. Because when you create a string, you just create the string instance, right? It's somewhere in the memory, but when you print it with this function, then it displays in the command line. So for this as well, we have a read method. It's not a function, it's a method associated to this instance. Then once you display the window, then you want to close it with window.close, another method. Right click and run. Now this error, if you go up, you want to read the error from top to bottom. So here, the first line tells you where the error originated. So in line 5. That means when the interpreter went to this line, it tried to call this method, read, but then the method, if you see down here, the method is defined somewhere, just like a function is defined. So if I click here, it's going to take me actually to where the method is being used by the files of this library. We don't need to look at this actually. As I told you, these are implementations details of the library itself, so we don't need to change anything here. But I wanted to show you that there's a chain of errors that happens in that library because we did something wrong, and we can read the details in here. It says value error max arg is an empty sequence. Now this error is not so well described by the authors of this library. They could have done better. So this is one of the hard to solve errors because it doesn't give us much information. The only clue here is that this says a sequence. And I know from experience that this layout argument, so types also have arguments, just like functions do, but I'm going to talk about that when you learn about types and classes later on in the course. So this layout has to be a list. Lists are sequences. So let's run again. Again, this says that this is an empty sequence, so this sequence has to have something inside. So let's put an empty string there. Run again. And now no errors, and if you're able to see, this is the window we created. It has this close button, and that's it. So let me close this window and let's add some elements to this. I'm going to create a label element, which is equal to free simple GUI dot text. So a text type. Now we had a window type that created that small window. Now we have a text type which creates a label on a window. So it's not a string. A string is something that is displayed in a command line interface. This is something else, And this now needs an input. The input is a string instance. Type in a to do. So just like lists are made of other items, for example, we can have a list of strings, hey, and so on. The same goes here. This text instance can have also strings. The only difference here is that this has to be a string. So for lists can have anything, but this has to be a string here. So that is a label. Let's create an input box as well, which is equal to free simple GUI dot. Now, since we are using this free simple GUI name over and over again, and this is hard to type, we could do something. We could say import py simple GUI SSG. And now this name represents that name. Then that means we can replace this with SG and this with SG and this with SG as well, and things will work exactly the same. So now SG dot input text. And this can be empty, you don't need to put any arguments there. But if you like, you can say tooltip is equal to enter to do. And let's execute. So run GUI. And we still see the same window because now we created these instances, but they are floating somewhere. We haven't connected them to the window instance. So the window instance has to be aware of these. So let's make the window instance aware of these two instances. To do that, you want to go to layout and put the label there and the input box as well. And these two have to go inside another set of square brackets. I'll explain why. But first, let's right click and run the program. And this is what we've got this time. So that's the title, My To Do App, which reflects the title of the window instance. And then we have type in a to do. So that is the label, which reflects the text instance. And that is the text box. If I hover the mouse, I see this enter to do label, which is the tooltip. So this is a program we generated. Now about this syntax here, layout is equal to square brackets, square brackets. So layout expects a list. Layout is an argument and it expects a list, and this will be a list of object instances, buttons, text boxes. So first we have the outer square brackets, right? And then we have inner square brackets. Now the items you put inside this inner square brackets will be placed in one row. You see the label is here, and on the right we see the input box. So if I wanted to put the input box below type in a to do, I would do this. I would put the label inside square brackets alone, and then the input box inside square brackets also alone on itself. So that means now we're going to have one row here and one row in here. So first go to the program, close it, and then rerun it. You see type in a to do is here, and then the input text is below that label. Let's add a button. So I'm going to name this add button. This is going to be the button which adds to do. We're going to have more buttons later, such as the edit button, the complete button. Therefore, I'm going to use different variable names for each one. sg.button. This is also an instance which is created by the button type. Give a label to the button, such as add. Check to see if the program is running. No, it's not. So I'm going to run. sometimes it doesn't show. So in that case, you want to click over the program in the list of your open programs and quit it there, perhaps, and then run again. So now it's working. Oh, but I forgot to add that add button variable in here. So where do I want to add that button? Do I add it in the same row with label? If that is the case, that would be like that. Run and button. The button is here on the side. But it makes more sense to remove it from here and put it on the side of the input box. So go to the program, close it, run again. And there you go. Now you'd ask, what if we press that button? Nothing is going to happen, except of the program being closed. So nothing is happening because we haven't connected this button to any actions. We want to connect it to some functions. And we'll do that in the next video. So to wrap it up, what we did in this video was we created some instances of different types in here, and then we created an instance of a window as well, which basically is the parent of all these instances. So this mother instance contains those other objects, and that is possible through this layout argument, which we see in here. So layout expects a list of lists, and each of those lists contains 3 simple GUI instances. So a list is not just a sequence of numbers or strings. Lists can contain everything. So that is a Python list, and it contains lists of 3 simple GUI object instances. And then here, once we create those objects, then we want to display them. So this read method displays them. And then this close method closes the program when we press some buttons. So for example, if I print here hello and I run the program, you're going to see that hello is not printed out in here. That means the interpreter has executed the program up to here, but then here it halts. It suspends the execution and it waits for user action. So if you press anything now, this button or that button, then the interpreter will go on and go past this method, and it will execute the next lines, the rest of the lines. So let's try that. Let me close the window. Yeah, you see that hello now is printed out. So that was what I wanted to show you with this print function, that I wanted to prove you that the code is initially executed up to here. And that is going to be useful in the next videos when we add some interaction to this button, the add button. And now, before I close the video, I want to commit my changes using this git commit button. So press that. CLI.py and GUI.py are going to be selected, so select them if they are not selected by default. And we want to write a commit message, such as create basic GUI without interactions. And I'd also add day 16, just a note, since we are in this course, so it helps us keep track of the days as well. So why am I committing at this point? Well, because I think this is a milestone. So I commit now, and later if I want to go back to this milestone, I can. So Git allows me to see the code as it was at this point. Tomorrow we're going to develop the code even more, we're going to create a new commit, etc. So Finally, I'll press commit, and I've got this message: the commit was successful, so I'm done for the day. I know it was a long video, but the purpose was not only to show you free simple GUI, but also to help you understand how types work. So built-in types that we saw before and third-party library types such as the window type that we had here. This will help you understand Python better. So thanks a lot for following. I'll see you in the next video. Hi, in today's code experiment we're going to run a few experiments on the GUI. Currently we have this output. So now I'm going to change something here on the widgets line and see how that will really reflect in the output. Now I do suggest that when you close the app, don't close it with that button, but stop it here. This is as long as we are developing the program. This is a better way to stop the program. Otherwise, you might have some errors. Later on, we're going to create an executable file of this program, which means that you will not need Python to execute this program. Anyone can get the program and they can use it on their computer. They don't need to have Python installed. They don't need to know Python. So it's going to be a distributable file. Then we're going to close a program using that button or another exit button, which we will add to the GUI. So now let's focus on the experiments. Look at this list of lists here. What happens if we remove all the inner brackets inside the list and we only leave one pair of brackets, so the opening square bracket here and the closing square bracket here? If I run the code now, we're going to get this error. And this particular line here is important to understand what's going on. It says that instead of a list, the type font was class PySimpleGUI. So what it's trying to say is that this list has to have other lists inside. So this is a flat list with other items, but you need to have another square of brackets, and then you can put the PySimpleGUI widgets inside those brackets. So in other words, each row in the GUI has to be a list. So basically you have the bigger list first, the outer list, and that list will contain a list of rows. So each row in the GUI has to be its own list. So now if I run the script, we're going to have one single row. You see now that label, input box and add button are in one single row. Label, input box and the add button. So having them in a list puts them in one single row in the GUI. That's something I wanted you to be clear about. Now let me stop the program, and if you place something like a string here, like hey or whatever, or here you put a number and you run the program, you're going to get an error. I think that's what you expected as well. So these things have to be PySimpleGUI widget types. So that is a specific type which creates these widgets. Otherwise things will not work. And the last experiment again is related to the widgets. If you place everything in a separate list, so every widget is inside a list like that. So now we have a list of 3 lists. That's the first list, that's the second list, that is the third list. And that is the entire list. Now you should be able to forecast, to predict the output. So try to think, what are we going to get if I run the script now? If you guessed it, you're doing well, very well. So we got a GUI with 3 rows. In each row we have one widget. So we have the label widget in the first row, we have the input box widget in the second row, and we have the button widget in the third row. So as I said before, each list inside the lists represents a row, and that proves it. So let me stop the program, and that was the code experiment for today. Thanks, see you later. Hi, welcome back. Throughout today's and tomorrow's bonus example videos, you will learn how to build this app. This is a file compressor. So first I'll demonstrate you what this app does, and then we go ahead and build it in this video. So today in this video we will build the graphical user interface, and then tomorrow we will implement all the functionalities of the app. So this is a complete version of the app, and the way it works is this. So here we have these 2 buttons. The first button is used to select the files that the user needs to compress. So for example, if I press on choose and then I go to a folder, I select one file or multiple files pressing the by holding the shift button pressed. For example, I selected 3 text files, I press on open, and the paths of those files are reflected in here automatically. So these are absolute file paths. And then this other button allows me to select the directory where the zip file is going to be created. So that can be any directory, so I'm just choosing this one. Choose, and the path of the directory is also reflected in here. And then if I press compress, I'm going to get this message that the compression was successful, and then I go to the destination folder, my files, and that's the zip file that was created. So if I extract it, I'm going to see a folder with all those 3 files inside. So that's how this app works. Let's go ahead and build it now. I'm going to create a new bonus 16.py file in the bonus folder. And then import free simple GUI. So you saw from the output that in the first row we had an sg.text object, so it was a label, and we create labels using that text type to create text instances, label instances, whatever you call them. So that was select files to compress. And then we had an input widget, sg.input. Then we had that choose button on the side. So far we have select files to compress, that label, this input box, and this choose button. Now the button let's call this choose button 1 because we have 2 buttons, one here and one here, so this will be number 1. And the button is not a generic button, so you don't want to use sg.button, you want to use files browse and then write the label of the button. In our case it is choose. So this is a special button because it's already programmed to select files. In the other button we built today for our to-do app, the button can take different roles depending on what we write. So afterwards we're going to program that button to do specific things. But this button is a special case of a button. It does one thing only, and that is to allow the user to select files on their file system. So as you saw in the demonstration, this is what this does. So it allows the user to select files. Right, let's go ahead and create some other widgets. The second line. I'm just going to copy these because the second line is mostly the same, and change label 1 to label 2, and then here select destination folder, and this will be input 2. It's still an input text box, so that one in here, this, and then the choose button this time is not file browse, is another specialized button. It's called folder browse. So this will be choose button 2. And we're going to keep the same label for that as well. And that's what we have for now. So let's go ahead and create the window object now, which is equal to sg.window. We want to give a name to the window, such as file compressor, and then we want to give the layout argument, which is going to be a list of lists. The first list is the first row, so it's that first row, which contains label 1, input 1, and choose button 1. So those three items. Label 1, comma, input 1, comma, choose button 1. That's it. So that's the first list. A comma after the list. It's a good idea to split this into a different line because this line is getting too long. And also in here after the comma, so we write one list, after the comma we split it again, and this here will be the second list. So that's the first list, comma, second list. And this is the main outer list, these outer brackets. Right, the second list is label 2, comma, input 2, comma, choose button 2. That's it. Then we want to read the window, and then we want to close the window. So now it's time to run this program. And yeah, that's the output. The theme is different, and so later we will work on the theme and the size. For now, let's ignore those aspects and focus on building the widgets. So we have a label widget, an input widget, and a button widget. If I choose some files now, for example, I press the Shift key and hold it, choose multiple files, press on open, those files are automatically reflected in this input box here. The same goes for destination folder. I can go to some other folder, choose a destination folder, press enter, and that's the path of the destination folder as well. And before we close the video, let's also add that compress button. So that's going to be a normal button using the button type, compress. So I can add that as a separate list here. Compress button. So we have the first row, a comma, the second row, a comma, and the third row. I'll run this, and that's the final layout of our program. So tomorrow we're going to make this program alive so that when the user presses that button, the selected files are going to be extracted in the selected directory here. So see you tomorrow. Thanks. Hey, welcome to today's programming tool. Today you're going to learn how to use GitHub, and I'm going to take you step by step. We're going to start from creating a GitHub account to connecting your GitHub account with your PyCharm project, and then uploading your files to GitHub. As you know, GitHub is a code hosting site, so you can upload your code to GitHub, and that code in GitHub is synchronized with your code. Let's now go through the steps of setting up GitHub and using it. So our project is currently connected to Git. We did this in yesterday's programming tool. So if I press on the Git tab here, I see I have 2 commits. So if you haven't followed yesterday's programming tool video, you need to go there and set up Git. Right, with that in mind, you can open your browser, search for GitHub on Google and go to github.com. GitHub is free, so you can go ahead and go to sign up to create a new GitHub account. So just enter your email and your other data such as your password. I've created a GitHub account already, so I'm going to sign in with my username and password. So once you have signed up and signed in, you can go to this icon and go to new repository. And you should see this view. So what is a repository? A repository is basically a project. So for every PyCharm project that you have, for example, we have this project where we're building this to-do app. For every PyCharm project, you want to have a GitHub repository. So you might give this a name which is related to your project, such as to-do app. So to-do-app. This is saying that this is available because I don't have such a name in my GitHub account. Therefore, the name is free. And then you can give a description if you like. I'll just leave it empty, it's optional. And then you can set this repository to public or private. If you set it to public, that means everyone on the web can see your project files. So they can see your code, they can download your code. They cannot modify your repository, so they cannot modify your files, but they can see it. If you don't want your files to be seen by anyone other than the ones you share your URL with and you give them access to, then you want to choose private. But you can change later. For now, I'll just keep it private. I can switch on public later on in the GitHub settings. Then these, you can leave them as they are and press on Create Repository. And this will give us this URL in here. You can copy that by selecting it and copying it, or you can press this button to copy that URL. Then you want to go to PyCharm. So now we want to connect our project with that remote URL so that our project is uploaded to that remote URL, to that repository. To connect our project, we want to go to the Git menu and then go to Manage Remotes, and then you want to press the plus icon. Leave the origin name as it is, and here you want to paste that URL that we got from the repository. Press OK. This might ask you to log in via GitHub if you haven't logged in before, so you want to press login via GitHub. So PyCharm is trying to authenticate you to make sure that you have access to that repository. So then you want to go to authorize in GitHub. And that's it. You can close that page, go back to PyCharm, and this is added. So this URL is added now. It's part of this project. And actually, if you go to File, Preferences or Settings, and then you go to Version Control, expand that, go to GitHub. Now you'll see that my account, my GitHub account, is connected to PyCharm. So when we logged in via GitHub through that window, that PyCharm window, PyCharm added our account here. So let me cancel that, just wanted to show you. And next, so what can we do now with GitHub? Well, so far we have been doing these commits. So anytime we add some features, maybe we do some code changes, we do a commit, we register that change or that new feature, the code for that new feature or the code for that change. We register those changes in Git through a commit. And then by the end of the day, once you have done several commits and you feel like you did a lot, then you can do a push to GitHub. So we have commit, which is this button here, and now we have push, which is this other button. If you press that button, you're going to see the list of commits here, which you haven't pushed yet to GitHub. So leave that as it is and just press on push. And what that is going to do is it's going to upload the newest files, the newest version of the files to GitHub. You see I got this message, pushed master to new branch origin master. So if I go to GitHub now and wait a while, maybe a few seconds, and then refresh the page, and this is what you should see normally. So all these are the files we had in our PyCharm project. If you click any of them, you're going to see the contents of those files. You see the directory path here. So to-do app is the repository, and functions.py is in that repository now. So these are all the files we have included in the version control. All the files we have included in Git. So Git is associated with GitHub. So GitHub will get only the files you have added to Git. And if you click here in this commits button, you're going to see the history of commits. For example, if you want to see the files as they were in the initial commit, you want to press that last button, and this is all the files as they were back then. So that is also something you could do in PyCharm. I showed you yesterday that you could do this by using that checkout revision, and that would also display the files as they were in that initial commit. So you could do a checkout when you want to see the files and maybe you want to run them. But if you just want to see the files, then perhaps you could just go to Github and use what I just showed you. So again, you go to the repository, you go to commits, that's the list of commits, and that button contains the code of all the files as they were at that particular commit. So that's about it. We're going to keep using Git and GitHub. We're going to keep committing new changes and pushing those changes to GitHub in the next days also. So thanks a lot for following this. See you later.